We are working on section 7.1, which is solving linear systems by graphing. There are actually two ways to solve linear systems. One is by graphing, and the other way is algebraically. We're going to do the graphing today, and then we'll get into the algebraic ways in the next few lessons. You may wonder, what is a linear system? Well, it's two equations that have the same variables in them, usually x and y. Each equation would have an x and a y, which is why we can graph them. We can graph with x, y's in our equations. And there is usually one solution to the system, and that is a coordinate pair, an xy coordinate pair. And it's wherever the two lines intersect. And so as we are working on our graphing today, I'm going to expect you to be using a straight edge. You've got graph paper there. We've got to see where two lines intersect. So as we are graphing today, I ask you to use that straight edge because we want to make sure that we can see exactly where the two lines intersect. We don't want to have kind of a smudgy line that gets kind of wobbly. The first thing that we are going to do is some of the work is going to be done for you. On that graph paper that I gave you, would you just jot down these two equations and jot down the graph that is already done for you? Okay, I'll give you a moment to do that, please. As you're finishing up putting that graph on your paper for yourself, they did the work of graphing these two equations for you. That's work you're going to have to do in the future in this class, today even. But what I want to look at is the end result. What is the solution to a linear system? Well, first of all, these two equations right here are a linear system. That is two equations with the same variables. And so you have these two equations here, and you can graph those two equations by either using xy table, xy intercepts, slope intercept. You could do many ways. They've already got it graphed for you. Where do the two lines intersect? Can you tell me the xy coordinate pair of where the two lines intersect? Jared?
2, -5.
They intersect at 2, -1. So we went 2 over 1 down. So we're looking at 2, -1, this spot right here in the middle. How do we know that that is really the answer? Jared, what can you do? Substitute the numbers back in. So when you look at this, 4 times 2 plus 3 times -1. What's 4 times 2, class? 8. 3 times -1? -3. What's 8 minus 3? Does 5 equal 5? Yes, true statement. Okay, so we know it works for the first one. Let's check on the second one. 2 times 2 minus a -1. Please be careful when you have a negative sign in front of your variable. You have to apply that to whatever number you're putting in for the variable. Minus and minus becomes a positive. So here we have 2 times 2 is 4. 4 plus 1 equals 5. 4 plus 1 is 5. 5 equals 5. Again, a true statement. So then we know that this is the solution to our system. We found it by graphing. It's one of the things you're going to have to do on my first quiz and on the test is you are going to have to solve a system by graphing. You're going to get two equations, you graph them on the coordinate plane, you look to see where do they intersect. Any questions here so far? I would always check my answer to make sure that it works in both equations. That way when you hand in your quiz or you hand in your test, finish up with your homework, you know that for those problems you have the correct answers. Okay, just like we did in chapter 3 where you could check your answer back into the equation, you know whether you, when you handed in the test or the quiz, whether you had 100% or not on those problems. I don't want you to copy down this graph. I just want you to look at it and tell me what is the solution to this system. Can you look at the graph and see where the two lines intersect? Chris, what do you say?
3, 4.
3, 4. 3 over, 4 up. So we write down 3, 4. Let's just check this mentally. This is going to be the opposite of x, which is -3. And what's 3 times 4, class? 12 plus a negative 3? 9. Okay, that works. Okay. 4 times 3 is minus 4. Gives us the 8 there. That also gives a true statement. So we know this point right here where the two lines intersect, this is going to be our answer. It works in both equations. So your answer here is an XY pair. Any troubles? One more. Tell me where these two intersect, please. Tell me what the solution to the system is. These are the toughest ones of the whole day, right? What do you say, Mason?
Negative 1, negative 1.
Negative 1, negative 1. So we're looking at negative 1, negative 1. 5 times negative 1?
Negative 5.
Minus a negative 1.
Negative 4.
Negative 4, because that's 5, actually negative 5 plus 1, isn't it? Negative 2 times negative 1. Positive 2. 2 minus 1 then is 1, which is a true statement. So if you can check that mentally when you are doing your problem, that's fine. There are going to be some homework problems where they're asking you if it's a solution or not, and I'm going to expect to see how do you know it is. I want to see that work. But just on here, you could check your answer mentally. You don't have to show me. I would encourage you to check though. Any troubles here so far? Okay, most of the work was done for us there. Let's do a little graphing ourselves. Here are two equations. If you would jot down those two equations and graph them. Feel free to talk to your partner about graphing. In terms of graphing, I would either use XY intercepts or slope intercept, depending on what works best for the problem. See that Jared and Ben have these graphed for us. Where do the two lines intersect? What is the solution to this system? What do you say? Where do the two lines intersect? I need you guys to start thinking here. I know you don't have lunch till 4th hour. Your brains are probably kind of hungry. But we got to start getting into it here. Samantha? 2, negative 3, she says. We're going over 2 and down 3. So when I write that answer is written as an XY pair. Let's check it to make sure. We have 2 minus negative 3. Minus the negative 3 becomes plus 3. So 2 plus 3 is? Works for the first one. 2 times 3? 6 minus 3? Is 3. Works for the second one. So Samantha's answer of 2, negative 3 is our solution. We put a box around that answer. That is our solution. And we did that by graphing. Remember I said on your quiz, I'm going to ask you to solve by graphing. I'm also going to ask you to solve some algebraically, a different method that we'll learn in future days. So this is what I expect to see for graphing. I want to see the two lines graphed. And then I have to see what the numbers are for the XY pair of where they intersect. That one was pretty easy, wasn't it? How about this one? Why don't you start graphing this one, please? All right, if you have yours graphed here, like Josh and like Connor have, you have them graphed correctly. Natalie, question?
Okay, I have a really stupid question.
Okay,
How
go.
are you getting that? Like, how are you getting the graphs?
Okay, let's take a look at these. I think with the guys, the way I saw them graph here, they did the XY intercepts. So they put 0 in for X, Y
Okay.
equals 6. And then they put 0 in for Y, and X is going to be a negative 6. And when you plot those 2 points, Natalie, that's this point here and this point here, you can draw your line through your X and your Y intercepts.
Gotcha.
And I believe that's how Josh did the second one as well.
Okay.
But then I reminded him that if you were looking at it in terms of slope intercept, that's why I had him go up a little bit higher and to start a little bit further than just from dot to dot. All right? All right, now that we've got Natalie taking care of and graphing these, what's the solution? Where do those two lines intersect? Take a moment, talk to your neighbor. All right, what do you guys think? Any thoughts on an XY pair here? Josh? No, there's a solution. Do they intersect? Can you see that they intersect?
Yeah.
Okay, they intersect. They intersect somewhere. Okay. We'll talk about no solution in just a second because that's an option, but it's not on this one. Okay. Where do those two lines intersect? What's the XY pair? Anybody take a wild guess?
0.5.
So what are we doing? 1/2 or 3/4?
0.5.
1/2
And 6.5.
and 6.5. Okay, so you're thinking 1/2 over and 6.5 up? You're hoping? Okay, let's check to see if it works. Okay, I'm glad that you at least gave me a try, okay? So what's the opposite of 1/2? That's going to be a negative 1/2, right? Negative 1/2 plus 6.5 is 6. Hey, it works for the first one. Let's check it out on the second one. 2 times 1/2 is 1 plus 6.5 is, oops, didn't work for the second one. So it's not the solution because it didn't work for both. Pardon me? You have to guess and check. Unfortunately, no, I'm not going to make you do that. Here's the deal. I told you there are other ways to do these, didn't I? I said it was algebraic. This is not a good one to do graphically. Not all linear systems are good to do graphically. On your test, on your quiz, I will not give you a problem that you're going to have some weird fraction. Okay, 1/2, yeah, you could have 1/2, but some weird fraction, no. The actual answer is 2/3 and 6 2/3. That's what the actual answer is. See if it works. Negative 2/3 plus 6 2/3? 6. 2 times 2/3. Oh, come on, multiply fractions. 2 times 2/3. 4 over 3. Then add that to 6 2/3. It equals 8. It works. Ha. So this point over here is actually 2/3 comma 6 2/3. Okay, not the friendliest answer in graphing. Okay, I wanted to show you that sometimes you might get answers that are kind of weird, and you got to do the best you can in coming close. But there's a better way to find it out. That's an algebraic method, and we'll talk about those in the coming days. So that if you go, okay, they give me a choice of what I want to do, maybe graphing is not the way that I want to do it. Jared.
So I'm not going to get one of those on the home.
Not for graphing. Okay, you might have a 1/2. Okay, there might be a 1/2, but you'll see when you get your homework from me, Jared, I got a bunch crossed out because they weren't very nice. Last year's class and I decided those were not nice ones to do, and they agreed that you didn't have to go through the pain they went through last year. Okay, all right. Anybody else? Fabulous. And let's talk about this a little bit. We want to know if the ordered pair is a solution of the system or not. Whether it's a solution of the system or not. This is the ordered pair that we're looking at. How do you determine if that is a solution to the system? Chris?
Plug it in.
Plug it in. That's right. Plug them in for x and y, right? So substitute in negative 3 plus 1 equals negative 2. And negative 3 plus 5 times 1 equals positive 2. Do we get a true statement on the first one? Yes. How about a true statement on the second one? Yes. Then how are we going to write our answer? If it's true for both of them, how are we going to write our answer? It says, tell if the ordered pair is a solution to the system. Solution would work. Any other answer that might work?
So out of luck.
Pardon me?
So out of luck, SOL.
Oh, SOL, so out of luck, no. SOL solution I will take, but so out of luck I won't take. Okay. Josh?
Capital R.
No. I don't want, no, you're looking at what all of the solutions are, and it's not all real numbers. I just want to know if this is a solution. Is it a solution?
Yes.
Oh, yes would be a good idea. Yes, it's a solution, or it's solution. The other option would be no, or not a solution. This is where not a solution is appropriate. It says, is it a solution? Yes, it is. No, it's not. Yes, it is a solution. No, it is not a solution. They're just asking if this ordered pair is a solution or not. They're not asking for what the solution is to the equation. They're asking if this one is a solution or not. So please make sure that you get into your notes somewhere appropriate, because here, not a solution, would be appropriate kind of answer. The word solution on this particular problem is a correct answer. Yes would be appropriate here. Let's look at this one, please. Determine if this is a solution to the system or not. Talk to your partner about it. Is 5-2 a solution to the system? Yes or no? Solution or not a solution? Why? Why not? Jesse?
No, because
It doesn't fit in the second problem. Prove it to me that it doesn't fit in the second problem.
8 times 5 is 10, and 8 times 6 is
26, not 11. That is not a true statement. Since it doesn't work for the second one, this is not a solution. When Jesse said no, that was an appropriate answer as well. Tell if the ordered pair is a solution. No, it's not a solution. As long as it does not work for one of the two equations, it's not a solution. When they ask you in homework, check to see if this ordered pair is a solution. If you come up with it for one equation, it doesn't work, you don't have to check the other one. But if it works for one, you better check the other one. But if the first one you try it doesn't work, then life is okay. Okay, any questions there at this point? You're going to do some solving of some equations here for me. You're not going to do all of these. You have your grid paper. I just want you to do number 16 and number 20 right now with your partner, please. And we'll get some people up here to graph them in just a moment. Chris and Matthew have graphed the two sets of equations up here. On number 16, what do we consider our solution to the problem? What do we consider our solution? What do you say the solution is? Joe, what do you say?
For the first room 16?
For number 16, please.
4 for 2.
4, 2. As an XY pair, right? 4, 2. How about for number 20? What do we see as our solution to number 20, please? Savannah, what do you think?
-1, 4.
-1, 4. Have you guys checked those numbers? Do they work in the system? Did you check the numbers? Do they work? You didn't check them. Okay, we better check them. Let's see. What are we putting in here? 4 equals -2 times -1 plus 2. -2 times -1? 2 plus 2? 4 equals 4?
Yes.
Life is good. Okay, y is a 4, x is -1. So, -1 plus 5?
4.
4 equals 4?
Yes.
All righty. Let's check up here. We've got 2 equals -4 plus 6. -4 plus 6?
2.
2 equal 2?
Yes.
All right. And 2 equals +4 minus 2. 4 minus 2 is? 2 equals 2.
Yes.
All right. Then we know that the two sets work. It's a really good idea to check. Remember that one that we had before where Josh gave me those fractions? It looked close, didn't it? But it wasn't quite what we needed yet. So please make sure you check. When you're graphing story problems, remember that you can graph using XY intercepts. I highly encourage that on story problems. Guess what's next?
Story problem.
Hey, bingo, we got a story problem. You bought 15 1-gallon bottles of juice, of apple juice and orange juice for school dance. The apple juice was on sale for $1.50 per bottle. The orange juice was $2 per bottle. And you spent $26. I want an algebraic model. In other words, I want an algebraic linear system, two equations, and I want you to graph that system. I want to find out how many bottles of each kind of juice you bought. Talk to your partner, come up with the two equations, will you please? So let's talk a little bit so that you can start maybe figuring out these equations along the way. First of all, what does X refer to?
Orange juice.
Bottles of apple juice. So perhaps a good thing with linear systems is to write down what the variables actually refer to. X equals the bottles, and not the bottles, but the number of bottles of apple juice. What does Y refer to?
Number of bottles of orange juice.
Number of bottles of orange juice. Or in our house, OJ. Okay? Number of bottles of OJ. So you are given a couple pieces of information. You are given that you bought 15 bottles of juice. You are also given the information that you spent $26. Could you possibly talk to your partner now and maybe think a little better about some information? Okay. The equations that Kayla just wrote up here. X plus Y, the number of bottles of orange or apple juice plus the number of bottles of orange juice equals the total number of bottles, 15. Somebody asked me before, do you have to use the 15? Yes, you did. Okay, $1.50 times how many apple juice bottles you have, plus $2 times how many orange juice bottles you have. Money plus money equals money. So I needed that total $26 as well. Those totals give you a hint of what things to add together. So those two equations are correct. Now graph them. You have a graph there, it's going by twos. Go ahead and graph, talk to your neighbor. Graph those, please. All right, we have Ross and Luke graphed our two lines for us using x-intercepts and y-intercepts. Now the guess is, where do those two lines intersect? Talk to your neighbor a little bit. See if you can figure out where those two lines intersect. Okay, what are some thoughts we have in regards to XY pairs that might work? What do we think, Chris?
Algebraic.
No, I'm not doing algebraic right now. I'm doing graphing. Okay, that's what we're doing here, graphing today. What do you say, Josh?
9 and 6.
You think 9 and 6? Well, let's check it out. 9 plus 6 is 15. Life works good. Okay, now you got your calculator handy. What's 9 times 1.5? What's 9 times 1.5?
13.5.
13.5 plus 2 times 6 is, so what's 13 and a half plus 12?
25.
Ooh, 25.5 is not quite 26, so 9 and 6 is not a solution. Okay, it looks pretty close, but it's not there. Now, I know you guys are trying 9 and 6 up here also. Kayla, what do you say? Kayla wants to try 8 and 7. Okay, 8 plus 7 is 15, right? First one works fabulous. Okay, now take 8 times 1.5. 12. And 2 times 7 is? So 12 plus 14? Ha! There's our answer. That worked for both. So what we write up here is 8 bottles of apple juice. And we write 7 bottles of OJ. There is my answer. What's important with story problems, ladies and gentlemen? Labels. So, Andy, just for your information, labels on story problems, please. On a story problem, 8, 7 wouldn't get you very far with me. I need to know 8 what? 7 what? Now, what would have made the graphing of this better? What would make the graphing of this better? What do you say, Mason?
Instead of going by twos, going by ones.
Going by ones would probably make it a lot better. Yes. Yes, that would help out. Going by twos, the author kind of did us a disservice in going by twos. But life goes on, you adapt. Okay, questions there? You're going to do some graphing next with your partner. I'm going to have a joke sheet that you're going to work on.